Hello class 9. Today we are going to start with the numericals on sound. So the first question from the book itself is, the heart of a man beats 75 times a minute. So what is its frequency and time period? So let's look at the solution. So here the question says the heart beats 75 times a minute. So beats in 1 minute equals 75. That means beats in 1 second will be equal to 75 divided by 60, and this will be equal to 1.25. So now 1.25 beats per second means the frequency is equal to 1.25 per second, or we can say it is equal to 1.25 hertz. So the first answer, frequency, is equal to 1.25 hertz. Next we have to find the time period, and we know that the time period is equal to 1 by f, that is equal to 1 by 1.25, because f frequency is equal to 1.25, and when you simplify this or calculate this, you'll get this is equal to 0.8 second. So the time period is equal to 0.8 second is your answer. Next is question number 3. The separation between two consecutive crests in a transverse wave is 100 meters. If wave velocity is equal to 20 meters per second, find the frequency of wave. So the solution is, now you know that two consecutive crests means from one crest to the other we take it as a wavelength. So two consecutive crests has the length of 100 meters, means the wavelength is equal to 100 meters, and the wave velocity is given as 20 meters per second. And in the previous video we have learned that wavelength is equal to wave velocity into time period. This is like distance is equal to speed into time. This means that time period will be equal to wavelength divided by wave velocity. Alright. So what is the wavelength over here? It is 100 meters and wave velocity is equal to 20. So it is 100 divided by 20, which is equal to 5 seconds. So the time period is equal to 5 seconds. Now why we need to calculate the time period? Because we have to find the frequency. Okay, we cannot directly get the frequency. We have to use this formula, wavelength is equal to wave velocity into time period, and then we'll get the time period. And from here we know that time period is the inverse of frequency, that is f is equal to 1 by t, and the value of t is 5, 1 by 5. So calculating this, you'll get 0.2 per second, that is equal to 0.2 hertz. Alright, so this is the answer for question number 3. Next is question number 4. A longitudinal wave travels at a speed of 0.3 meters per second and the frequency of wave is 20 hertz. Find the separation between the two consecutive compressions. So over here we have to find the separation between two consecutive compressions, means again we have to find the wavelength, right? So it's given wave velocity is equal to 0.3 meters per second and the frequency is equal to 20 hertz. Now we know that time period is the inverse of frequency. So time period is equal to 1 by f, which is equal to 1 by 20. That gives us the the time period equals to 0.05 seconds. Now again using the same relation, wavelength equals to wave velocity into time period. Just put the value of wave velocity, that is 0.3 meters per second, and multiply it with time period, that is 0.05 seconds. So when you multiply, you will get 0.015 meters, which is equal to 1.5 centimeter. Or in proper way, if we write the answer, then we can write it as 1.5 into 10 to the power minus 2 meters. Because in SI system, we try to write our answers in SI system, and SI system means the length has to be written in meters. Alright, so 1.5 into 10 to the power minus 2 meters becomes your answer. Question number 6. An observer A fires a gun and another observer B at a distance 1650 meters away from A hears its sound. If the speed of sound in air is 330 meters per second, find the time when B will hear the sound after firing by A. Alright. So the distance between A and B is given, that is equal to 1650 meters. And the speed of sound in air is 330 meters per second. Now we have to find the time taken by sound to reach from A to B. Alright. Now the time, as we know, distance is equal to speed into time. Therefore time is equal to distance by speed. Okay. So we can say distance is 1650 divided by 330. So when you divide it, we'll get this is equal to 5 seconds. Okay. So 5 seconds becomes the answer. Next question is question number 9. An observer sitting in line of two tanks watches the flashes of two tanks firing at each other at the same time. But he hears the sound of two shots 2 seconds and 3.5 seconds after seeing the flashes. If distance between the two tanks is 510 meters, find the speed of sound. Fine. So let's try to understand it using a small figure. So here there are two tanks marked by the two rectangles, and let's say the X is the position where the observer is sitting and observing. So over here the first tank which is away from the observer, okay, will take 3.5 seconds, and the second tank which is closer to the observer will take 2 seconds. Okay, the sound will take 2 seconds to reach the observer. So the distance between the two tanks is given as 510 meters. So if distance is equal to 510 meters, therefore time taken to travel by the sound from the first tank to the second tank can be obtained by subtracting the two time periods, that is 3.5 seconds minus 2 seconds. That will be equal to 1.5 seconds. Now we know that the speed of sound can be obtained by using the relation distance by time. And the distance between the two tanks is 510 meters, and the time taken to travel between two tanks is 1.5 seconds. So this we can just take it as 510 divided by 1.5, which will give us 340 meters per second. So this is your answer for question number 9. So similarly you can try out for your assignment. First you will copy the given numericals on the exercise book, and also you'll do exercise 8A, page number 183, question number 2, 5, 7, 8, 10 and 11. Thank you.